Hello and welcome to Civil Engineering Skills. This is a short introductory video to the whole of this course and then a bit more detail about the first 6 weeks. So the whole module overview is that in semester 1 for the first 6 weeks you have myself, and we're going to be learning how to communicate through drawing, both using hand drawing skills and also using Autodesk Revit, which is a BIM piece of software where you can create 3D visualizations and also embed them with information. From week 7 you have a reading week in week 7, and then after that you'll be with Andrew Liu doing computer programming. And then in semester 2 you'll have Alma doing surveying. You may also, if you're on the AED course, do some manufacturing. And the architecture students will also have some sketchbook work to do in semester 2. The first 6 weeks of the module has certain outcomes. It's always worth looking at the module sheets to see all the outcomes. I've just highlighted 3 here. You can read those for yourself, but it's to do with making sure that you can communicate through both hand sketches and via computer aided output. The way that the course will work for the first 6 weeks is you'll be listening to videos like this, getting some direction on what to do, and then on the Friday there will be a 2-hour synchronous tutorial between 10 and 12. And alongside that, throughout the whole of the week, there'll be a discussion board available on Blackboard. You'll have a number of exercises to do, which I'll go through in a moment, both hand drawings and Revit drawings overlapping each other. There'll be videos on Blackboard to support you for the skills you need for all the exercises. So the best way to get the most out of the sessions on the Friday is to actually watch the videos and try the exercises, potentially have fully completed them, and then come to the tutorial to ask any fine questions or any difficulties you're having or any clarifications. If you just turn up on the Friday session having not looked at anything before, they won't be very useful to you and you won't be able to find you'll get much feedback from them. So let's go through week by week what I'll be expecting you to do. So first of all, watch this video. Hopefully you're doing that. And then also this week before Friday, try exercise 1, which is on Blackboard, and try and draw the Revit house using the Revit program. So download the software, get used to the basic controls and see if you can actually draw the house. If you have questions and problems on Friday, please ask us, but don't just try starting uploading the software on the Friday morning. In week 2, you'll be doing a hand drawing of the house and be able to compare the difference between doing it digitally and doing it by hand. You'll also have exercise 3, which will be the Revit steelwork and schedule. Very important to understand that the 3D software, because it's intelligent, you can embed it with information, so you can schedule out components and ask how many columns, how many beams, how much they weigh, what their carbon footprint is, all sorts of questions by knowing what to put in for each of your elements that you're putting into the drawing. So we'll work on that in some detail. In week 3, you will hand drawing the steelwork and get some hand drawing done properly. In exercise 4, you'll have a Blackboard quiz on how to read drawings for the coursework, which starts this week as well. you will have to read some actual construction drawings of an actual building that's in Sheffield. We'll give you a starting point, but you've got to be able to read the construction drawings. So the quiz leads you through a series of questions that are answered on the drawings and gives you some hints if you can't get the answers, but it's important to be able to read those drawings. So the coursework will be continuing from week 4. In week 5 we'll also do a little bit of hand drawing showing viewpoints and perspective. In week 6 we'll do an exercise on how to peer mark other people's work and how to give feedback, and that will then be the end of the course, but you've still got to submit your coursework, which isn't until week 8. And then when you submit the coursework, this is so that we can give you some feedback on it, and you can also give other people feedback on their work. These will all be anonymised, but you'll actually be receiving a mark for the feedback that you provide, rather than the actual quality of your first submission of the Revit coursework. You'll have a chance to resubmit the Revit coursework in spring next semester, where you'll get a mark for the actual work after incorporating the feedback you get. If you go via the student handbook, you will find an assessment deadline sheet. This is the current version of it. Please go back and check tracker. But this gives you an idea. I've just filtered it for Civ 1900. You should be able to understand which course you're on, whether the Civil Engineering Skills or the Civil Engineering Skills with Manufacturing, CESN, and be able to say, okay, I can see my 100% that I need to get, and each of these percentages should add up to 100 depending on which course you're on. So what can you expect from us? University teaching is slightly different from what you've been used to at A-levels. We are not just going to give you something and say regurgitate it. So are we going to give you all the information and the answers to help you pass the course? No. However, we will give you the information to help you find the answers yourself. So we're not going to read the drawings for you and say this dimension should be this value, but we'll show you how to read drawings so you can find the answer yourself. We'll give you lots of feedback on your work. It's important to understand what feedback is and what forms it takes. So for instance, we'll give you written feedback when we give you some feedback for, say, for instance, a quiz. When you get the answer wrong or right, we may say, yes, this is correct, well done, or have you tried looking at this area of the drawing? Spoken, so there'll be live sessions on Fridays where you'll be able to speak to us, written in discussion boards, and then guidance in tutorials, etc., as well as kind of a peer feedback. So civil engineering, the degree you've chosen, is a very, very broad subject. So here are some definitions. You can see the first one mentions the word art, the art of directing the great sources of power in nature for the use and convenience of man. Second one uses the word science, the science of constructing docks, railways, canals, etc. In reality, it's a combination of both. We'll tell you a lot about the science. It's an applied science, but there's an art form associated with what you're going to do rather than how you're going to do it. The word design is formulated from being able to formulate, draw out, plan, sketch out, and in French the same as the word draw. So civil engineering design is the determination of what is to be built. That's the important bit, and then the preparation of the instructions necessary to build it, including all the design and sizing. But the determination of what is to be built is getting more and more important. So in practice, engineering is a teamwork event. You don't just do it on your own. You work in teams. It's a creative process. You run ideas past people, but it's underpinned by scientific concepts. We'll teach you both at university. The best people are the people who can look at things from many different angles and come up with an option or a very good option for a particular need from a client. So here's an example of a complex problem posed by a client. Here's the site. They want to build something interesting within this site, but the final formation levels aren't yet known because it's a working quarry. This site ended up being this, which you may recognise, the Eden project down in Cornwall. Well worth a visit if you get a chance. But an interesting solution for the reuse of a quarry site, a very big visitors attraction. So we're teaching design because whilst you've probably come through a STEM kind of subject background, you go through this degree, you'll become highly numerate, you'll be able to work with complex mathematical problems, but sometimes we can lack creativity. So we need to make sure we put ourselves in situations where we do have to actually think about what we're doing rather than just turning the handle, if you like. So design is far more than just the analysis of the solution done by others. We get involved by what's going to actually be produced. That will include some creative thought, some balance of cost, the practicalities of construction, the environmental issues. You're aware I also teach on CIV173, so things like carbon footprint will become far more important, along with conservation of nature and habitat. And you'll have to work with other multidisciplinary teams, other professionals, architects, project managers and so on, to come with a solution. It won't just be civil or structural engineering. So we're wanting to make sure that you can communicate your ideas and can communicate them well. You might have some really good ideas. If you can't communicate them, then they're not going to go anywhere. And one form of communication, alongside reports and written work, is visualization. So from initial meetings with clients, giving them an idea of what they are thinking and what you might be able to come up with as a solution is a very powerful way of coming up with options. Discussing things with the design team, looking at options, issues, discussing it with other statutory bodies, down to the actual formal instruction. Once you've decided what to do, down to the site workers, exactly how and where and when to build. And very, very often we communicate this down to the general public. You'll see many sites in Sheffield with visualization on their borders of their fences, telling you what's actually going to be built behind the fence that you see. So visualization becomes an important part of what we do. So I'll finish this video here and continue a couple more videos on the introduction to the hand drawing element and the Revit element. Thanks for listening.